If you are new to the channel, then subscribe the channel and press the bell icon for further notification. In series, so today again we will be solving 5 questions starting from question number 6 to question number 10. Okay, then let's try to solve these questions. Okay, in question number 6, the torque speed characteristics of a repulsion motor resembles with which of the following DC motor characteristics? So why repulsion motor is used? So you have to remember all these main applications. So repulsion motors is mainly used in electric trains. So what is the purpose of electric trains? The main job in electric train, it should have high starting torque. So which motor gives you high starting torque? Your DC series motor gives you high starting torque. So the repulsion motor is basically the concept of that DC series motor is used to achieve that high starting torque, and that's why it is used in train. So you have to use remember its usefulness, where it is used, and what is main characteristics of that motor. So it's a high starting torque. Initially you can think of, there are lots of, again in repulsion you will find lots of repulsion type. The basic idea is taken from DC series motor to give you more starting torque at the beginning. So that's why it is option C. Now if you come to question number 7, a 200 volt 10 kilowatt lap bound DC generator has 10 poles and 500 conductors on its armature. If the pole face covers 80% of the pole pitch, the pole face conductor requires to fully compensate the armature reactions will be. So compensating winding are given in these pole shoes. Suppose this is one pole, there are other poles, are there 10 poles, I am drawing one pole. So why this is given? This is given to compensate the armature reaction. Armature reactions is nothing but this is producing a magnetic field, this magnet, and if armature current flows, then these also produce magnetic field which react with this magnetic field. So to nullify that reaction, you connect a compensating winding in the pole shoes which is in series with this current, and in such a way so that it opposes this magnetic field created by this one, because this one is not required. This is original magnet, whatever magnet it is, and this compensating wire connected in series with your armature winding so that it produces same magnetic field like your armature magnetic field, so that these and these cancel it out, so it doesn't affect your original magnetic field. So that is the idea. So how many conductors are there per pole? So total is 500, divided by per pole it is 10. I am also dividing by number of parallel paths. Why dividing by parallel paths? It will be clear after little, just at the end. So you divide how many parallel paths are there, because it is lap bound. So P, it stops with P, so number of pole is the parallel path, that is 10. So you can see it is 5 conductors. Okay, so there are 5 conductors here, each under this pole, but not exact 5. They have given the pole face. This is the pole face. It covers 80% of the pole pitch. So pole pitch here 5, but it doesn't cover that fifth one. Why? It covers 80% of this one. So 80% of this one, that means number of conductors under this pole, because that magnetic field will interact with this magnetic field. We don't look about other magnetic fields. So this 5 into 80% of that one, 0.8, that is 4 conductors. So that means there are 4 conductors per pole shoes. So if you put this 4 conductor, so it will put same magnetic field like it is. Now why this is, now you can see it is 4, so therefore 4, you need to have 4 conductors per pole. Now the thing is, why we have divided by this A. Now you can see there are 8, suppose this is the parallel paths. Suppose there are 2 parallel paths. So this is the I current, armature current, and these 2 are divided by I by 2, I by 2. So the magnetic field created by these and this is Ni by 2 by Ni by 2. So Ni by 2 plus Ni by 2, which is equal to Ni. Now if I can put, N is the number of conductor of this winding. Now if you put the same number of winding here in compensating winding, but in compensating winding current flowing will be the armature current, not I by 2I. So it will be Ni and Ni. They will cancel it out. So that's why I am dividing by that parallel path also, because here total current will flow, not division in parallel paths, because in parallel paths current will be divided. So each conductor will carry I by 2 if there are 2 parallel paths. If there are 10, there are I by 10. So summation of this give you Ni, but here I will flow. So that's why you have to make conductor divided by 10 so that Ni remains same. So that's why it is divided by. So now you can understand the answer is 4 conductors per pole. So a 240 volt DC shunt motor with the armature resistance of this and a full load current of 40 ampere. So when there is a full load, then 40 ampere current flows. Find the ratio of the stalling torque to full load torque when the resistance of 1 ohm is connected in series with the armature. You will be inserting one more resistance there in the second case. So you want to find the ratio of torque. Now torque is directly proportional to phi into Ia, but in the shunt motor phi is fixed because you are fixing this voltage. So whatever voltage it comes here, same current will flow here, because this resistance is fixed, this winding is fixed. So this phi is fixed. That means T1 by T2 would be equal to IA1 by IA2. So the first condition they have given already. IA1, if I consider that 40 ampere current is flowing through there, so it is 40. That is T1 is given. That is the ratio of ratio of the stalling torque. So this is stalling they are asking, and this is full load. So full load is taking 40 ampere. I2, that is second case is given. This one you have to calculate. So what is IA in stalling case? Stalling means N is 0. So if your N is 0, then EB, that is phi Z and P by 60A, that will also become 0. Once your EB becomes 0, then you can find your IA, what is the current will be here, because you know EB is equal to V minus IA RA. So your IA will be equal to V is 240, and so here R is now 1 and then 0.5, so it is 1.5. So your IA will be 160 ampere. So you put it is 160. In the first case, initial case, it was 40 ampere. In the now stalling case, it is now 160 ampere, because your N is 0, EB is 0. So from here I have calculated. So the ratio is 4:1. So that is your answer. That is 4. That is option A. Now if you come to question number 9, a 4-pole lap-wound DC generator has developed a power of P watt, voltage of E volt. Two adjacent brushes of the machines are removed as they are worn out. If the machine operates with the remaining brushes, the developed voltage and power that are obtained from the machines are, because it is lap-wound, so you have number of parallel paths is 4. So there are 4 parallel paths. So let me draw it in this way. Suppose this is one parallel path. So there is one brush here, one brush here, one brush here, one brush. 4 paths you can see. All these paths will carry I by 4 if the total current is I. So because it is delivering power, so power should come out of positive terminals. So these two should be positive and these two should be negative brushes. Okay, now if you see, you can start from anywhere, because I is entering through here. So I will have 2 branches now, I by 2, and this will have I by 2. Now this I by 2 will have again 2 branches. So this will carry I by 4. This will also carry I by 2. So first I, then 2 branch, I by 2, I by 2. Then this also divided by I by 4, I by 4. So this will also go divided by 2. Now you can see there are 4 branches and each branch carries I by 4. All are parallel paths. Now you can see this I by 4 plus I by 4 will give this I by 2. This will also give I by 2. And I by 2 will get it at I. So this was your E voltage between these 2 terminals, and P was the power, which is E into I. Now suppose any 2 adjacent brushes. Suppose if I cancel this brush and this brush. These 2 brushes are ground. Now this current cannot go, because this current cannot come here. So this I by 4, these I by 4 will not be collected. So only currents will be collected through here. So you can see now, so this is your I by 4. So this current I by 4 will flow here. So at the end you will get, the voltage will remain same. The voltage between these and these will all remain same, because this between these 2 means between these 2. That is the voltage, because it is connected in parallel. So V. But power will be equal to E into now I by 4. So power will be divided by 4. So that is option C. E will remain same, but power will be divided by 4. So here list 1 and list 2. List 1 is no load or block rotor test. It is test actually. Then Sapna test, then Swinburne's test. I think you know all these tests. No load and block rotor test. So you can see by seeing this side also, it should be connected in motor, because block rotor means you will block the rotor, then you will rotate and they will do the test. So it should be done on some motor where you can block this rotor. So obviously transformer it will not be. Synchronous machine generally we always think of generator, and DC machine we don't do. It is actually done for induction machine, that block rotor test. So you know this one, no load and block rotor test. It is, so A is obviously 2. So if you see A is 2, then only option A is correct. So you can directly give option A is the correct option by seeing only no load and block rotor test. But you should also know this one. This is Sapna test. This is done back-to-back transformers for ideal transformer. Both the transformers should be ideally look like similar, and they are connected in back-to-back, so that you can find out the loading effect, to calculate the loading effect of the transformer. So obviously B will be connected with 1, and then C, Swinburne's test. It is in DC machine it is done. Generally in shunt or compound machine, calculate the constant loss, that is your iron loss. So that is Swinburne's test, which is in DC machine. So obviously C is 4. That is option A. If you like the video, then press the like button and please give your valuable comments in the comment section.